This lesson is about the distributive law and combining like terms. First, we need to talk about some vocabulary. First word is number. I think everybody knows what a number is. Then we have a variable. And a variable is a letter that represents a number. So, for example, it could be x, a y, t, n, s, etc., or maybe even a. It could be any letter. But the idea is that we don't know what number the letter represents. Kind of a mystery. So we just use the letter to represent the number instead. Numbers, as we know, they could be like 1, 2, 4.5, 3/4, or negative 2.6. The third vocabulary word is term. A term could be a number, like 3 or 5, or it could be a variable, like t or x, or it could be a number multiplied by a variable, like 3x. And when we have a number multiplied by a variable to make a term, you don't need to put in the multiplication symbol. It's just understood if the number is next to the letter, then they're multiplied. So 3x is an example of a term. Or you could have like negative 2y, that's a term. Or you could have even negative a, which is the same as negative 1 times a. We just write it as negative a. That's also a term. Okay, and the fourth word to know is expression. Now, an expression could be a number, like 3, or it could be a variable like t, or it could be a term like 3t, or it could be two terms added together. For example, 4 plus t, or you could have 7 minus 2x, or you could even have 3 terms or more added together. You have 1 plus x minus 5y plus another 2 x's. Okay, so remember, number, variable, term, and expression. Now we'll spend a little time talking about simplifying expressions by combining like terms. What does that mean, combining like terms? Well, it just means that if you have 2 apples and you have 3 bananas, those are my bananas there, and then you add 2 more apples and you add another banana, how many apples am I going to have altogether? Well, I can combine the apples together, combine the like terms, and I end up with 4 apples, and I end up with 3 plus 1 bananas, 4 bananas. You can't call this 8 apples because you can't combine apples with bananas. Okay? So, but let's do an example with some algebraic expressions. Remember what an expression is? So let's say we had, change the color here. Let's say that we had 3 plus 2x plus 3x plus 5. Well, this is an expression, and that's fine, but even though I don't know what the value of x is here, I can still simplify the expression, because I know that if I have 2 x's, no matter what x is, if I add 3 x's to it, I'm going to end up with 5 x's. So these two terms, since they're both x terms, can be combined. Similarly, the 3 and the 5 can be combined because they're just number terms. So number terms can be combined, and then variable terms can be combined as long as it's the same variable. So the simplified version of this would be 5 plus 3 is 8, and 2x plus 3x is 5x. 8 plus 5x. Okay? Let's do another example here. Suppose I had 1 minus 2 plus 5x plus 2y minus x plus 3. Okay? Now I've got 2 different kinds of variables here. What am I allowed to combine? Bonnie, what am I allowed to combine?
No. 1 minus 2
Mm-hmm.
plus 5. No, not the plus 5.
Yep, I can't add the plus 5 because it's 5x. But I can add the 3, can't I? Because that's a number, so I'm combining the like terms. So the 1, the negative 2, and the 3 can be combined together. What else can be combined together? Bonnie?
Uh,
5x with the...
2x?
Nope, that's a
No.
2y, so I can't combine it with it. With the negative x. Yeah, these two can be combined together. And then this one, this 2y, stays by itself. It has nothing to combine with. So let's write that out. So if I do 1 minus 2 plus 3, I get, let's see, that's negative 1 plus 3 is positive 2. So we've got 2. And then 5x minus x is plus 4x. Right? So if I have 5 of something and then I take away 1, I'll get 4 of the same thing. And then the 2y has to stay by itself, 2y. So 2 plus 4x plus 2y. Okay, so let's do a more complicated example now. Suppose I have 3 times n minus 2 minus 8n times 5n. I'm sorry, let's not do that. Let's not have a quadratic term in there. And then we'll have 8n times, 5 minus 2. And I want to simplify this expression. Well, I've got to combine the like terms, right? Can I combine this n with the 8n? Well, not really, because I've got these parentheses here that make things tricky. So the first thing to do when you're combining like terms is you got to multiply out the parentheses and get rid of them. Okay? And that's using the distributive law. You remember what the distributive law says? It says that if I've got something multiplied on the outside of the parentheses, I can distribute it through on the inside by multiplying by each one. So what's 3 times n? So that would be, if I distribute this quantity here, I get 3n, and then 3 times negative 2 is negative 6. So I've got 3n minus 6. And then over here, I have to remember to keep this negative sign. So what's negative 8n times 5? Well, you multiply the numbers together here. 8 times 5 is 40. So, but don't forget the negative sign. So we got a negative 40n. And then what's negative 8n times negative 2 if I distribute it through? Well, a negative and a negative makes a positive. 8 times 2 is 16, and I've got just one n. So I got plus 16n. So what I've done here is I've distributed through and gotten rid of the parentheses. So now that I've done that, I can combine like terms. So Bonnie, which terms can I combine now? If I got 3n minus 6 minus 40n plus 16n.
You can combine those.
Oh, when you say those, they can't see your fingers. The negative 40n
Negative 40n plus 16n.
plus 16n, that's right. And also this n, right? So these three can be combined together. And then this lonely number has to stay by itself. Okay, so let's do that. If I have 3 n's and I take away 40 n's and then I add 16 n's, let's see, 3 minus 40 is negative 37 plus 16. That's a little bit tricky, but let's see. 27, I think it's negative 21, I think. Is it? Let's see. 3 plus 16 is 19. Yeah, negative 21. So I've got, so what this turns out to be is negative 21n minus 6. So we took this complicated expression up here. Whoops, I turned that 2 into a 3. That's horrible. Okay, let's not do that. Okay. So I took this complicated expression up here and ended up with just kind of a simple one, negative 21n minus 6. The idea is no matter what I plug in for n, I'm going to get the same answer. Let's try something. Can you pick a small number I can plug in for n, just as an easy example? Bonnie? 1. Good idea. So let's say that n was equal to 1. Let's test if we got the right answer. N equals 1. Well, if I plug in 1 here, I get 3 times negative 1, because 1 minus 2 is negative 1, minus 8 times 3, because n is equal to 1, right? And so I end up with negative 3 minus 24, which is negative 27. Let's see if I get the same answer if I plug n equals 1 into that one. Well, I've got negative 21 times 1, which is negative 21, minus 6, I hope this comes out, is negative 27. Hooray! Look at that. I've got a match between this negative 27 and that negative 27. That's the whole idea of simplifying expressions. When you simplify an expression, no matter what n is, these always equal each other.
What if n was 3?
If n was 3, well, go ahead and try that out on your own. I don't have time in this video to show that. But I would like to do one other example here. Suppose that I had 6, for extra practice, times 6x plus 5. I'll just go through this one quickly here. And then I had plus 8 times x minus 5. And then let's say I had another plus y here. Okay? Well, we kind of know that the y is going to stay by itself, don't we? It can't combine with anything here. But to be able to combine these x's, I can't just go and say, all right, this is a 6x and that's an x, so that makes 7x. No way! Because I've got to distribute first, right? So you got to get rid of the parentheses first. So distribute here, change the color, and I've got 36x plus 30, try that on your own, plus, it's easy when there's pluses and not so many minuses here. I've got 8x minus 40, plus this lonely y at the end. How do I simplify this? Well, I can combine like terms. So the 36x can combine only with the 8x, and the 30 can combine only with the negative 40, right? So I end up with 36x plus 8x is 44x, and minus 10 for the numbers, and I have this lonely y that just stays by itself. That's the simplified expression. All right, to finish up, Bonnie, your job is to plug in a value for x and y and see if these come out to equal. But we can't do that right now because we're running out of time. So see you later.